friends, welcome to my channel and welcome to another video of the series Plating Techniques. In this video, we will learn the estimation of throwing power of an electrolyte or a plating bath solution by using Haring-Blum cell. For those who do not know the meaning of throwing power, you can watch my video number 2 in the series. Link for the video should be visible to you on your screen on the right top corner. Briefly, throwing power of an electrolyte can be defined as the capability of a solution to produce uniform deposition of metal on all sides of the substrate. Now, this parameter can be determined by using an equipment called as Haring-Blum cell. Now here is a simple setup of Haring-Blum cell where you can see that there is one anode and two cathodes, cathode 1 and cathode 2, and all these electrodes are suspended in a container that contains the electrolyte whose throwing power is to be determined. Now if you observe keenly, cathode 1 is kept at a distance of d1 centimeters from the anode, which is greater than the distance of cathode 2 from the same anode. Now this is the way you are going to set up the Haring-Blum cell. That is, D1 has to be greater than D2 all the time. Overall, what we will be measuring in this experiment is the distance between anode and cathode 1, distance between anode and cathode 2, and the amount of metal that will be deposited on cathode 1 and cathode 2. Using these measurements, we will be calculating the percentage of throwing power of a plating bath solution or an electrolyte. Now, in order to understand this experiment in further details, let us have a look at observations. Now, observations show that there are two sets of readings that we will have to take. One, prior to deposition of metal, and other after the deposition takes place. So prior to deposition, you will be measuring initial weight of cathode 1, initial weight of cathode 2, then you are going to fix them in the equipment setup and measure the distance between cathode 1 and anode, distance between cathode 2 and anode, and you will also be recording for what period of time you will be passing the current through the solution. Once you have recorded all of this, now you can begin the experiment where when current is supplied, anode produces metal ions and cathodes attract metal ions for the reduction reaction, and hence metal gets deposited on both of them. So eventually, when you pass current for a certain period of time, cathode 1 and cathode 2, both of them will gain weight. So once the decided time is over, you are going to stop the supply of current. Then you will take second set of readings, that is post deposition. You will measure final weight of cathode 1, final weight of cathode 2, and using this and the values that you have taken prior to deposition, you will be getting the amount of metal that gets deposited on cathode 1 and amount of metal that gets deposited on cathode 2. Since the distances are different, definitely there will be difference in the amount of metal that gets deposited. And obviously, the nearer electrode will get more metal deposited, and the other electrode, which is at a greater distance from anode, will have little less amount of metal deposited. Now, once you have these values, you will go for calculation, which can be done using this simple equation, where percentage of throwing power is equal to x minus y divided by x plus y minus 2 into 100, where x is equal to d1 by d2, where d1 is the distance between anode and cathode 1, d2 is the distance between anode and cathode 2, and y is equal to w2 divided by w1, W2 is the amount of metal deposited on cathode 2 and W1 is the amount of metal deposited on cathode 1. Once you substitute these values, you will get X and Y, and once you substitute X and Y in the above equation here, you will get the percentage of throwing power for that plating bath solution or the electrolyte. Now using this value, you can estimate what kind of quality of deposition you can expect. If percentage of throwing power is high, or say 100%, the uniformity of deposition can be assured. If percentage of throwing power is little less, then uniformity can be a question. The amount of metal deposited on the substrate may vary a little bit in thickness. So that is how percentage of throwing power of an electrolyte helps us to identify the quality of plating bath solution in a plating process. I hope the determination process of throwing power is understood. If you have any queries, you can post them in the comment section. If you understood the concept, give a like to this video and subscribe to the channel for the continuous updates on the plating techniques as well as other concepts of the chemistry. Now, in the next video, we will be discussing about electroless plating and making of printed circuit boards. See you in the next video. Take care and don't forget to subscribe to the channel for continuous updates.